Good morning to all. Today is the fifth day of this STTP, and we are going to start the first session. So today we have an eminent speaker, Dr. M Makwana sir, who is going to deliver his topic on energy audit. And currently he is serving as a principal of BN Ministry of Technology, Vallabh Vidyanagar. He has joined BBIT as a lecturer in Electrical Engineering Department in 1994. Then he became head of the Department of Electrical Engineering in 1999 and became principal since March 2010. He did his BE in 1993 and ME in 1998 in Electrical Engineering from LD College of Engineering. He completed his PhD in Electrical Engineering from SP University Vidyanagar in 2014. He is also a Bureau of Energy Efficiency Certified Energy Auditor and GEDA approved energy audit consultant. He has conducted numerous energy awareness programs, seminars, and delivers expert lectures. He has taken many initiatives in community development projects, which have given boost to the vocational training programs in rural areas for school dropouts and unemployed youth. Approximately 5,000 youth have been trained till date under the community development initiatives. He has been elected as National Executive Council member of IST for 2020 to 2024. And he has also worked as a chairman of the Institution of Engineers India, Vallabh Vidyanagar Local Center from 2013 to 2015. So we have such a great personality with us today. So without wasting much time, I would like to hand over this session to Dr. K. Makwana sir. K. Makwana sir, please.
Sir, you are not audible, sir.
Sir, please unmute yourself.
Good morning, everyone. Today I am going to share my views on energy audit with the participants. Nowadays, energy audit is a compulsory process for designated consumers. Those who have a connected load about 200 kilowatt, they have to go through the energy audit compulsorily in a 3-year. So this become a very important topic. Now, what is energy audit? As Bureau of Energy Efficiency has defined energy audit. As energy audit is defined as the verification, monitoring, and analysis of use of energy, including submission of a technical report containing recommendations for improving energy efficiency with cost benefit analysis and an action plan to reduce energy consumption. It's all about reduce energy consumption with cost benefit. So energy audit is a process through which we reduce the energy input. Now the whole process is, what is energy input and what is the useful energy? In a particular plant, we are utilizing energy. Suppose it's a 50 kilowatt of is the requirement, is the output of the plant. Then what is the input energy? Suppose it is a 55 kilowatt of energy is in we are putting in input. Then where this 5 kilowatt goes, that is the losses. So first of all, it is all the energy accounting. First of all, we have to establish the energy input. What is the energy input in the system? Then we have to identify the output. What should be the output? And then we can focus on energy losses. And we have to reduce these energy losses. When we reduce the energy losses, naturally the efficiency of plant increases. And that is the goal we need to achieve. So what are the losses and where these losses occurs? overall energy losses in a plant can result from designs. I would like to share one of my experience with you. We visited one industry which is making plastic items. They're producing plastic items, and they have, when installed the plant, they have a design of the plant for 500 kVA. They have 3 sheds, 3 production units, and they have planned that all 3 production units need 500 kVA of demand. So they have designed everything for 500 kVA. Then they started constructing the first phase. They have started that first phase, production of first phase, and somehow, due to any reason, they were not able to expand. They have not gone for the second and third phase. Now what happened? The first phase, which is working, needs only 200 kVA of power, sub 2000 kVA of power. The whole design is for 500 kVA, while utilization is restricted to 200 kVA. Now, this is the difference. For any reason, what we design and what is the actual operating conditions, there is a gap between two, and we have to identify this gap, because this gap, transformer of 500 kVA supplying the load of 200 kVA. So this is the difference. This is the mismatch, and there are so many mismatches you can find in any industry. This is a big issue. Everywhere you can see that when we design anything, we design on the condition given to us, while the actual operating conditions are always different, and it causes many losses. It unmatches the parameters, and during the audit process, we have to identify these mismatches, and we have to fill this gap. The second reason, operations that run on inefficient methods. See, normally healthy O&M practices in the industry can save a lot of energy. In one of our industry I have audited, what I have seen is they have a motor. It's a wire drawing industry. Wire drawing industry is they have a particular diameter of wire kept with them. So they elongate that wire, they stretch that wire and make the wire of the desired diameter. And this is the process. They put one die in between and they pull the wire through motor, and they get the desired diameter of the wire. This is the process. Now, when we check that motor on full load, the motor was taking 35 ampere of current. And while the wire is not connected, they were not stretching the wire, they were not pulling the wire. At that time, it takes 32 ampere of current. And the operator was taking proud that without the even load, it takes 32 ampere, and with the load, it takes just more 3 ampere, just 3 ampere more, and the work is going on. So our motor is very efficient. I said, see, the no load current should be 30-40% of the full load current. But here, 32 and 35, no load current, it was actually not the no load current, because our mechanism is remain connected with the motor. But the mechanism was such a hard and even not properly treated, and therefore it was creating such a load that it takes 32 ampere, and on full load, while actually production takes place, it takes only 35 ampere of current. So I said, there is something big wrong with your mechanism. Check it, and looking at the size and load of the mechanism, it should take 15 to 20 ampere of current, not more than that. So they have corrected it and current reduced to almost 17 ampere because there was a problem with the mechanism. So proper O&M practices in industry is very much necessary, and through that we can reduce the loss or minimize the losses. Another thing is poor or non-efficient energy consciousness maintenance. See, certain inefficient methods, when we talk about the inefficient methods, in one industry, they have 3 compressors. The industry was producing some small metal parts for instruments. Now, to producing that small metal parts, they were using compressed air for the production. So they have 3 compressors. The most efficient compressor they were using at that time. And what they did for the production, they were using the compressed air at high pressure. And for the cleaning of the same component, they have taken the tap of the same air and they were cleaning the components with the same air, which is not required that much high pressure. So high pressure air is being wasted in cleaning the components. For the cleaning purpose, they need a compressed air, but at a very much lower pressure. So for the sake of simplicity, what they did, they were using the most efficient compressor. That is true. But the compressed air they were using for cleaning is high pressure air, which is not at all required. So what we did, we asked them to start one new other compressor, which is quite not efficient. But then also, because it has to deliver the low pressure air, and it saves the energy. So there are so many inefficient methods, so many O&M practices and design problems. These are the issues which create the energy losses. And during the audit process, we have to identify these losses, we have to document it, and we have to identify the methods through which we can reduce these losses and increase the efficiency. Reducing these losses will substantially increase the plant's efficiency, but we need data to identify and quantify the losses and subsequently suggest suitable techno-economic solutions to minimize the losses. This data can be acquired through energy audit. See, first of all, we have to quantify the losses. We have to identify the area where the losses occurs. We have to quantify it, and we have to find out the techno-economic solution. These techno-economic solutions are very much necessary because everybody understands the language of money. No management will convince with that you can save this much unit, you can save this much power, whatsoever, you can save this much fuel. But when you say you can save this much money, they understand that language better way. So you have to give them a techno-economic solution, and that works, and that we can achieve through energy audit. So identification of the losses, quantifying the losses, providing the techno-economic solution to reduce that losses, and document it is an energy audit. There are 2 stages of energy audit. One is the walkthrough or preliminary audit. In a walkthrough audit, we just visit the facility, we see here and there, we take some documents, we study those documents. It's a one-day process, and we have to complete the task in a 1 day almost, and we have to make some suggestions. This is the primary audit, or say walkthrough audit. Second is the detail audit, in which we study each and every equipment that consume more energy. We have to go through the whole process of a production or process whatsoever, and complete study is a detailed audit. In walkthrough audit, for example, I have given the case of that three compressed air or the compressors. That is the walkthrough audit. We have just gone through the industry, we have seen the plant, and at the first instant, while talking with the staff, we realize that, do you need that high pressure air for cleaning? They say, no, this much high pressure air is not required at all. Then with the low pressure air, you can work. Then they say, yes, we can use the low pressure air for the cleaning purpose. So when you go through the any plant, you can realize that where the energy is much more used in a particular plant, you have to focus on that. And in just one visit, you can realize that here the losses occurs are more, or the method used is not proper, or you can make the quick suggestions. And you have to see the bills, you have to see the energy utilization pattern. On that base, you can suggest. Like in that industry, what I've said, plastic manufacturing industry, they have a 500 kilowatt of demand while they were utilizing 200 kVA. It is clearly visible at the first instant. So what you can see at first instant is the walkthrough audit. Now detailed energy audit. This is the extension to the walkthrough audit. By collecting more detailed information of energy use, identify all the energy conservation measures, performing detailed financial analysis of each measure to justify the increment. Again, I am saying that financial analysis of each measure. When you say you need to correct the power factor, if you correct the power factor, these are the benefits, these are the financial benefits, and you have to make the investment of a PFC panel like this. You have to invest this much lakh of rupees. If you invest this much lakh of rupees, annually you will get this much benefit. That you have to identify, you have to put in your report, and then it will work. Steps to complete energy audit. First, the plant visit that we normally do in walkthrough audit. Observe the various operations, process, production facilities, identify major energy consuming systems, including lighting, power, mechanical energy, etc. During the plant visit, we have to see that which are the equipment or which are the processes which consume most of the energy. And we have to focus on those equipments, we have to focus on those processes, and then we have to focus on it. That where the losses are mostly occurred, we have to identify those losses. Study of documents. All plant utility system diagram. Plant operation and maintenance procedures. Annual energy bill and consumption pattern. See, we have to study 1 or 2 or 3 years energy bills, electricity bills or fuel bills, etc. When you see the bills for last 1 year or last 2 years, you can establish the energy pattern, that how the plant is utilizing this energy. And this pattern is very, very important, to which you know that which process occurs at what time and how it is impacted the energy bills. The energy consumption and energy bills, these are very important things, because we have to reduce the bills. Our focus should be on reducing the bill through energy saving, because the management and staff will understand the language of money. And we have everywhere during the audit, we have seen that They are not interested in saving energy. They are interested in saving bills. So, study of energy bill, study of all the diagram of plant, and study of their operation and maintenance procedures are very, very important. And through this document, you can identify so many things. You can identify so many losses. So, study of document, it is the second stage. Third is the plant inspection. Identification of major energy consuming process equipment, taking field measurement to substantiate operating parameters, conducting detailed trials and tests. 70% of all the electricity is consumed by motors, electric motors. Now all the energy is input to the 70% of the energy that is produced, electricity produced is consumed by the motor, but not exactly by the motor. The mechanism like fan, compressor, pumps are connected to the motor are consuming the energy, while motor is a driving force. But as the electricity is input to the motors, it is counted that the 70% of electricity produced is consumed by the motors. So each motor efficiency is quite important. So if suppose it is a 5 HP motor, you will not go for all the tests. But if you have a 50 HP, 100 HP motor, then you have to conduct that efficiency test. We have to prioritize this, that which are the major components and what is the efficiency of that major components. Even when you go to the industry, they do not have nameplates on their motors. We have seen that. What is the capacity of the motor? Then say it's a 50 HP somewhere around, but there is a no nameplate on the motor. Even they do not know what is the capacity of that motor, because the motor is functioning, production is going on, and therefore they have no problem with that machine. How many times it is rewinded? Even sometimes they do not know it. It creates the problem. They go to the repairer, rewind it, again put it there. In one salt manufacturing plant, what I have seen is they have two motors. They need only one motor. They have two motors, one spare motor. 50 HP machine is required there. They have another motor of 150 HP. When something happened to the 50 HP motor, they replace it by 150 HP motor. Why they were using 150 HP motor? Because the motor was available quite cheaply to them, and they have procured that 150 HP motor second hand. It was many a times rewounded. And what is the efficiency of machine? When asked to them, they say, see, normally we use the 50 HP motor, but when something happened to that 50 HP motor, we replace it with the 150 HP motor. So these are the very important things during the energy audit. And in one another surprising thing is, and when auditing a big mall, now normally for the mall, shopping mall, air conditioning plant is consuming a lot of energy. They have huge air conditioning plants. Now this air conditioning plant, secondary pump is always connected with PFD. We know that the air conditioning load right from morning 8 to night 12, the temperature varies, outer condition varies, and the load on the air conditioner also varies. So in the noon part, where the load is maximum, while in the morning and while at the night time, the load is quite low. Even it depends on the flow of the people visiting the mall also. when the load of the people is more, the load on the air conditioning system is also very high. So the parameter continuous changes. So the secondary pump, speed of the secondary pump should be adjusted in such a way that it gives the maximum efficiency to the plant. And that's why VFD is attached to that secondary pump. In most of them all, while talking to the manufacturer of air conditioning plant, VFDs are not working in most of the plants. Why? Because it creates trouble sometimes. The people operating the VFD do not know the troubleshooting of the VFD, and they always give a bypass for the VFD. So when VFD creates the trouble, they bypass it. And once it is bypassed, it remains bypassed all the time. While it is saving right 10-15% of energy. A VFD, the speed of the secondary pump saves, controlling the speed of the secondary pump saves 10-15% of the energy. But VFD remains bypassed all the time. So plant, while inspecting the plant, we have to consider all these aspects. Staff interview. The operators, those operating the machines or operating the processes, are very important because they know everything about that machine or process. So we have to discuss all the points with this staff. In one of the machine at Ahmedabad, Torrent Power, earlier it was Ahmedabad Electricity Company, one motor of 4 megawatt. There was one motor of 4 megawatt. So while discussing with the staff, the engineer said, when anything happened to that motor, we are instructed that please don't use your knowledge, shut down the motor and ask to the higher management what to do, because it's a 4 megawatt motor. So the staff operating that machines have some critical information about those machines, even how many times motors are rewinded, they know it. What are the problem with this machine? They know it. How the losses can be minimized in any process is also known by the staff or technician working in that plant. So we have to take the interview of that staff also. Then comes the analysis. Detailed review of the energy bill of all the purchased energy for the previous 12 to 36 months, energy and material balance and energy loss waste analysis. Now all the things are available with us. We have the data sheet, we have identified the efficiency of a particular machine or particular process. We have energy bills, we have visited the plant, we have interviewed the staff. So all the details are available with us. Now with all these details, we have to analyze the energy efficiency of the particular plant so that we can identify the losses and we can set the target that how much losses can be reduced. Also, we have to establish the energy and material balance, because sometimes wastage of material also causes energy loss. Efficiency in use of material also reduces the energy. So we have to establish both the flow chart of energy, that how much energy is getting input, in which process or in which machine, how much energy is going, what is the output, and where the losses occur. We have to establish the whole energy accounting, that this much energy is input, this much is loss, and this much energy is being utilized. Identification and economic analysis of ECMs. The minor operations modifications offering no-cost solutions or low-cost solution with quick paybacks for any industry of mid-size. You can find some no-cost solutions. You go through any process and you will find that certain machine operates unnecessarily. They remain on when it is not required. This is the simple thing that we can identify. Why this machine is running? It is required. It is required, but at certain time, not all the time. Just because of the knowing that this machine is operating unnecessarily, they keep it on and it consumes energy. So these are the no-cost solutions. You can identify so many no-cost solutions in a larger plants or in a mid-size industry. When if you visit once only, you can see that these are the no-cost solution or these are the wastage of energy. We can stop it. So no-cost solutions are very important because everybody likes it. It saves the energy without any investment. You have to do nothing almost to save that energy. So no-cost solution is the first in our report. Second is the low-cost solution with quick paybacks, like loose belt, or if you want to change the speed, change the pulley. And if you see that small motors, if you can replace or you can rewind effectively, then you can save some energy. So these are the low-cost solutions, small changes which require some cost, but it gives a good saving. So these low-cost solutions, these are also very important because it can be implemented very easily and quickly, and within a week or a couple of weeks you can get the results. So these are the two things. The most important thing in energy audit are the no-cost solution and low-cost solution. Everybody accept it. Even go to the management and say, see, these are the low-cost solution with the payback. Like if you change the belt and you can save the energy within a week, you can have a payback of for that whatever investment you have made. So these paybacks are very important. Again, they understand the language of money. If you change the belt, which costs 2,000 rupees, you can save the energy equivalent to 2,000 rupees within 15 days. And then after, you can save 2,000 rupees for a longer period of time. This is the language they understand. So no cost solution and very important. Then develop major ECMs for each of the energy consuming systems, process, power, lighting, etc. Now, in a particular process, we see that a particular machine is quite old. If you can replace that machine with the energy efficient machinery, new machinery or new technology, then it requires substantial investment. Management may be agree or not, do not agree, but it depends on how much energy we save and what is the payback period. That is the very much necessary here. So we have to identify what are the energy conservation measures for each of the machine, each of the process, and we have to document it. The implementation cost, energy savings, and simple payback period for each of the investigated ECM. We have to recommend energy conservation measures. We have to list it, but just listing it is not only important thing, but implementation cost. I suggest that your 10 kilowatt motor is quite old. It was many a time rewounded. If you can replace with a new motor then it will save this much energy in a year, which is equivalent to this much rupees, and the investment in a new motor will pay back in 1.5 year or 2 year or 6 months or a year. You have to calculate it. And the whole thing is presented in this manner only. One, energy conservation measure, what is the implementation cost, how much energy is being saved, how much money will be saved, and what will be the payback period. Simple payback period. That in a year, 5,000 rupees will be saved, and my investment is 10,000 rupees. Then my payback will be 2 years. That much simple understanding we have to put in our report. For each of the energy conservation measure we offer to a particular plant. Finalize the list of energy conservation measures and review with the plant manager. Sometimes, because plant manager is aware with everything, their machines and their production. Also, when you put energy conservation measure, it may affect the production for a particular time. So plant manager may be agree with you or not agree with you. So we have to discuss everything with the plant manager after finalizing the energy conservation measures. Because we are not the master of that process. Plant manager is the master of that process. So his advice or his contribution in this process is very much important. So finalizing the list of ECM, sharing it with the plant manager, taking his advice is very much important. Then comes the preparation of final report. All the results are summarized in a final report. The report contains first description of plant operation and process. The whole process we have to describe in a couple of pages that what the plant is doing. Then discussion of all major energy consuming systems equipment. In the particular operation or in a particular process, these are the equipments or these are the systems which is consuming most of the energy. We have to define it there. Description of all recommended energy conservation measures with their specific energy saving potential. That we have discussed in the last slide, that for each energy conservation measures, we have to quantify how much energy it will save, how much money it will save, and what is the payback period. And what is the specific energy saving potential of that ECM for the future also. And cost of the ECM's implementation. At the end, how much cost they have to invest, how much investment they have to do in these ECMs. If they want to implement these ECMs, then they have to invest this much money that we have to put there. Cost benefit and payback. And we have to show that what are the cost benefit and what are the payback period for each of these ECMs. So this is the preparation of final report. Now the report is prepared and we have to submit it to the management where the energy auditor's job is over. But there are certain things which is not coming into these 7 steps. That the benchmarking energy performance. See, normally in a larger industry like cement, paper, textile, this benchmarking is very much important. They are doing it in our country also. But in a smaller industry or in a mid-sized industry or in certain processes, this is not the practice here. But we have to do it. We have to benchmark the energy. That production or process benchmarking like kilowatt hour per meter for textile unit or kilowatt hour per ton of refrigeration for air conditioning plant. What should be the benchmark? This much kilowatt hour per ton of refrigeration is very, very important. This is the benchmarking for cold storage. Suppose for the cold storage, what is the billing done throughout the year? What is the total billing in a year? And how much ton of refrigeration produced? You simply divide it, and that is the benchmarking of a kilowatt hour per ton. And we have to follow that benchmarking for every month and every year. When your energy bill increases without increase in the production, you will realize that something going wrong in your plant. This is the one point which show that something need correction, or we need audit, so that we can bring that come to that benchmarking level. Also, external benchmarking with similar industry. In our industry, we have established our internal benchmarking. Now we have to compare it with our peers. That for the same process, for the same industry, what is the benchmarking, established average benchmarking for the country or state? And we have to compare ourselves with that. It should not at least increase than that benchmarking. This is the standardization of the energy use. And if in our report we can make such benchmarking, that this is the benchmarking for suppose 2 units per meter of textile product, 2 units per meter of production of textile product. Then for the next year, what should be what is the benchmarking level? Then say 1.9, because the energy ECMs are being implemented. It becomes 1.9. You can show that this much energy is being saved per meter of textile product. That is very important. So benchmarking is again comes under the part of energy auditor. If you can do it, it is the best. Fuel and energy substitution. Maximize the use of a non-conventional energy like replacement of steam electric water heater with solar heaters, replacement of coal fuel oil with sawdust, risers, coconut shells. Natural gas is always a good replacement in recent years. Now, how we can use the non-conventional energy in a particular plant? Now, solar heaters are a quite efficient and good option for steam or electrical water heaters. Where we can replace it, because many industries use steam electric water heaters. We can replace it with the solar. Or we might have another substitutions also with the non-conventional energy, like sawdust, risers, coconut shells. We can use it as a fuel where intensity doesn't matter. So we can replace coal with the sawdust, risers, coconut shell, etc. So what the fuel or the process replacement we can give? Natural gas. We have seen that in the last 15-20 years, the use of natural gas in many industries has changed the energy scenario. So use of natural gas is also very important. The component of electrical energy audit. Area cover under the electric audit are electrical distribution system. Second is the power factor improvement study, transformer optimization, cable sizing and loss reduction, motor loading survey, lighting system, electrical heating systems. Mechanical system audit, fans and blowers, exhaust and ventilation system, pumps and pumping system, compressed air system, air conditioning and refrigeration system, cooling tower. So you can say that electric motor consumes 70% of total electricity produced. But actually motor is not consuming these items: fans, blowers, exhaust, ventilation system, pump, pumping, compressed air conditioning system, refrigeration system. Motor connected to these components is consuming 70% of electricity. So these components are very, very, very important. Efficiency of these components are very important. Thermal energy audit, steam generation boilers, steam audit and conversion, steam trap survey, condensate recovery system, insulation survey, energy and material balance for unit operation, heat exchanger, waste heat recovery system. In carry out the thermal audit, it is said that whatever you do in a thermal area, you can save energy. Just you color the outside of the plant or inside of the plant, you will save some energy as far as the thermal energy audit is concerned. So a lot to do in our country in this thermal energy audit. Process versus equipment. When we focus on equipment, we can save up to 5%. But when we focus on process, we can save 15% to 30% of energy. Because process involves so many equipments. The matching or synchronism between these equipments is very much important. When you lose that synchronism, you will lose energy. So process is the important thing. And you see, the most of the energy intensive industries are the process industries. They require a lot of energy. So we need to focus on both the area, but the process is the area where we can save maximum. One more idea is the demand side management. Demand side management is done from both the sides. Like utility system, electricity board can do the demand side management, and also the industry or the receiving end also can be made demand side management. As during our inauguration, I said that once while talking to the Chief Electricity Commissioner of Gujarat, he told that with the introduction of power factor penalty and to make 0.95 power factor compulsion on industry has reduced the peak demand of Gujarat state by 600 megawatts. It's a huge target just by implementing one administrative step. They have introduced power factor penalty. If your power factor is below 0.9, you have to pay this much charges. And if your power factor is above 0.95, you will get this much benefit. Just by implementing one thing, they have saved 600 megawatt of peak demand. They have reduced it by 600 megawatt. Two principal activities of DSM are load shifting and energy efficiency and conservation programs. Actually, while we improve our efficiency, our energy demand reduces, energy input reduces, which is in benefit to everyone, even for the suppliers also. Load shifting is again an important part. I will show you in the diagram. See, these are the sectors or industries. In industrial sector, consumption, overall consumption is 37%. Well, we can conservation potential is 25%. Agriculture 30%. Conservation potential is 20%. Transport, total consumption is 3%. And out of that 3%, we can save up to 20% of that 3%. Domestic and commercial, 27%. And we can save up to 20% of that. Yes, 70% electricity is used by the motor. We have repeatedly said that. Type of the load management techniques are load leveling, load control, and tariff incentive and penalties. In industry, normally, if you see that these are the patterns of load. At certain point of time, it takes the peak. We can clip this peak or not. If we can clip this peak, we shift the load sideways, then the peak will reduce. It will in turn reduce the energy bill. It will in turn reduce in the peak demand. So peak clipping is very just we have to shift the load from peak time to the other time. And time of usage charges is introduced that's why. Because in the morning hours around 10 and in the night hours around 8, the electricity board faces a peak requirement. So that peak keeping in a particular industry, also in case of the industry, peak clipping is very, very important. It reduces your demand and it saves the energy. Like load building, when we increase the load, instead of increasing the load this way, we can increase the load on sideway. While you shift the load or increase the load on sideway, when the peak is not occurring, at that time if we increase the load, it will give the benefit. So this is all about the demand side management. So demand side management is also one of the great tools for energy conservation. And we should, whatever we DSMB suggest is also a demand side management. I hope whatever I have said is useful to the participant. And in an energy audit, it's a very practical thing. When you go to any industry, you will see that there are so many chances of energy saving, but you have to quantify it. And quantifying the energy saving is the important thing. If you could not quantify, energy saving is there. We understand that energy saving is there, but how much? How much energy saving is there to convince the person that energy saving is there and this much energy can be saved and this much money can be saved? Then energy audit becomes successful. I hope that you must have got something from this lecture. Thank you. Thank you very much for giving me this opportunity. Thank you.
Thank you, sir. Hiral.
Sir, what is the pre-audit phase, or is any difference between primary energy audit and detailed energy audit?
Yes, primary energy audit is just one visit. We go through it, just go through the plant and view every process and identify the energy intensive areas. Just that is, we are not taking any measurement. We do not identify the efficiency of that plant, but just on the basis of document, just on the basis of energy bills and visual observation of the plant, we give some suggestion. That is the walkthrough audit or preliminary audit. While in detail audit, we go through the whole process with each component, each machine. We measure the efficiency. We detailedly prepare the report. Also, we show them the saving potential. We quantify it, and we submit the report. And also with the cost benefit analysis.
Okay, sir. Okay. Thank you very much, sir.
Okay. I think
one question from Professor Modi. If some industry have low power factor, what will be effect on grid network? Then it is a possibility of tripping.
Not of tripping, but when you have a low power factor, uh, you require more current, and ultimately you are loading the whole system, whole grid, because they have to supply the reactive energy. Suppose your power factor is 1, grid do not require to supply any reactive energy. But as your power factor reduces, they have to supply the reactive power also. So both you and grid both has a problem. So power factor should be above 0.95.
Okay, sir. Any other questions from participants? Yes, Hiral Bhadraki,
Yes.
sir, please.
Okay. Thank you, Dr. K. Makwana, sir. The sir has nicely presented the whole concept of energy audit, starting from the definition of audit and what are the factors that will affect the energy audit, what should be considered and what should not be considered. And he has also explained nicely the real example that he has faced in his tenure during the energy audit at different locations. And sir has also suggested that in which way the energy audit should be conducted, so that we can get the maximum benefit of energy conservations, as well as the company will also get the benefit in terms of financial profits. So thank you very much, sir. On behalf of this team and all the participants, we thank you very much for your nice presentations, and we hope that your presentations will definitely help those who are interested in this energy audit topic. Thank you all.